Hello everyone, we are today going to be talking a little bit about some special angles for some trig functions to help you with your lab this morning or this afternoon depending on when you meet. So I want to talk about three angles in particular, and they are the ones that work together in order to create the unit circle. So the first angle that I want to discuss is the angle pi over 6. So the angle here, pi over 6, and you have a graphic that actually gives these as part of a triangle. So we're talking about here pi over 6 here. This is our angle that we're referring to. And if we were looking at that particular angle, then that means that the hypotenuse is always, remember, the side across from the right angle. So 2s is equal to our hypotenuse. Our adjacent side is the square root of 3s. This is our adjacent side. And our opposite side is equal to s here. So when we're talking about the pi over 6 for our angle, we can find the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent of that angle based on this triangle. So if we're talking about sine of pi over 6, then sine is the opposite over the hypotenuse. So remember, opposite over hypotenuse gives us s over 2s. If we simplify the s's out, then what we get is that the sine of pi over 6 is equal to a half. For cosine pi over 6, the adjacent over the hypotenuse. Adjacent side is the square root of 3s. Hypotenuse is 2s. It should be a 2. Simplifying the s's out, you get the square root of 3 over 2. Later on, when you're working with the unit circle, you will notice that the 1/2 and square root of 3 over 2 values always seem to go together, and they will. So tangent of pi over 6 is your opposite side over your adjacent. So if we're looking at the opposite, we have s. The adjacent side, square root of 3 times s. Simplifying our s's out, you get 1 over the square root of 3. Or if we rationalize that denominator by multiplying by the square root of 3 over the square root of 3, what we get is the square root of 3 over 3. Now if we're looking for the cosecant of pi over 6, remember that that is the reciprocal of sine, so 2 over 1 or 2. The secant of pi over 6, reciprocal of cosine, so 2 over the square root of 3, and rationalizing our denominator, we get 2 square root of 3 over 3. And lastly, our cotangent of pi over 6. Cotangent of pi over 6, again, it's the reciprocal. So we started with 1 over the square root of 3, which means that we have the square root of 3 over 1, or just the square root of 3. So these are our pi over 6 for our special angles. We have two other special angles. One of them is pi over 4, and the other one is pi over 3. So in order of size, I'm going to say we're going to go with the pi over 4s next. So if we're looking at pi over 4, we are actually looking at this triangle here, which is our 90 degrees still in the corner, and both of those angles are equal. And so sine of pi over 4. Now, if both sides are equal, then it doesn't matter which angle that we're looking at. So here, we're going to call this one our angle. And that means that this one is our adjacent, and we have the opposite, and still the hypotenuse. So sine of pi over 4 is our opposite over our hypotenuse, so we have s over the square root of 2s. Simplifying our s's, I have 1 over the square root of 2, which when we rationalize becomes the square root of 2 over 2. Cosine, same thing, so this one is adjacent over hypotenuse, but the opposite and the adjacent sides are the same. So simplifies to the square root of 2 over 2 by the same arithmetic. For the tangent of pi over 4, opposite over adjacent, so we have s over s, which just gives us 1. For our reciprocals, cosecant pi over 4, we end up with the square root of 2. Same thing for secant pi over 4. And cotangent, reciprocal of 1 is just 1. For our last special angle, we work with pi over 3's. So pi over 3 is the last angle that we're going to need in order to make the unit circle today, and that this time we're working with this angle. So because we're working with that angle in red, now our opposite side is this one, and our adjacent side is this one. So as we make those relationships, if we're working instead with pi over 3, then the sine of pi over 3, looking back at the triangle, pi over 3, opposite over hypotenuse, so now I have the square root of 3s over 2s here. Simplifying out our x's, or s's, I have the square root of 3 over 2. Cosine of pi over 3, adjacent over the hypotenuse, so adjacent side here now is s, and our hypotenuse is 2s, simplifies to a half. Tangent of pi over 3, opposite over adjacent, so the opposite side, square root of 3s, adjacent side is just s, so we get the square root of 3. Reciprocals, you can just flip those over in order to find them. So these are our 3 special angles, and these triangles are actually what makes up the unit circle. Now, when we're talking about the unit circle, a unit circle has a center at 0, 0 and a radius of 1. So what that does, as far as the circle is concerned, is if you have an angle here, since the radius is 1, the s's simplify out. Now, if you are working with this particular angle t, for example, the cosine of t, because of this length of the unit circle, or the hypotenuse of the unit circle being 1, the adjacent side for that angle t is actually what simplifies out to cosine theta. And the opposite side simplifies out to sine of theta, or sine of t, which makes this corner here on the unit circle the coordinate xy, or cosine of t and sine of t. So this is what allows us, this relationship is what allows us to make the coordinates of the unit circle and relate those to cosine and sine of whatever angle you have. So looking at the picture a little bigger, if we're dealing with the cosine of t and the sine of t, whatever the coordinate is cosine and then sine as far as my x and y axis. We also have some points on the actual axes themselves. So if our angle here, if our angle T is 90 degrees, or pi over 2, then what we have is we have a quadrant angle, and here our cosine of pi over 2 is equal to 0, and our sine of pi over 2 is equal to 1. So working through the unit circle, you're going to work through the unit circle today, and then we will finish up module 2 on Monday, where we will build the unit circle in class and do some more relationships based on it. All right, have a good lab.